The objective for this lesson is going to be 1.4. I can find powers of monomials. And just like in the last lesson, we're going to look at some examples first and then see if we can come up with a pattern. So the first one we're going to do is going to be b to the fourth. Then this whole thing is going to be raised to the second power. So I know that means I have two factors of b to the fourth. So I have b to the fourth times b to the fourth. So I have 8 factors of b, so it's going to be b to the eighth. And then for the second example, I have x to the sixth to the third power. So that means I have 3 factors of x to the sixth. So I have x to the sixth times x to the sixth times x to the sixth power. So I have x to the 6, 12, 18th. I have 18 factors of x. And then for the third example, let's do y to the fifth to the second power. So I have y to the fifth times y to the fifth. So I have 10 factors of y, so it's going to be y to the 10th power. So if we look for a pattern here, I notice that 4 times 2 is 8, 6 times 3 is 18, 5 times 2 is 10. So this will be our rule. When you take a power of a monomial, so remember, monomials means one term, so only multiplying and dividing in exponents. You multiply the exponents this time. So let's use this rule to do some examples. So for the next example, let's do 3a squared to the fourth power. So this one I'm going to write everything out. And so I know 3a squared is really 3 times a. And then this whole thing is raised to the fourth power. So I have 4 factors of this whole thing. I took this and I wrote it out 4 times because I have the whole thing raised to the fourth power. So now when I simplify, I have 1, 2, 3, 4 factors of 3, and 1, 2, 3, 4, 5, 6, 7, 8 factors of a. Let's go back and see about our shortcut from before. What invisible exponent is really on this 3? It's really 3 to the first power. So if we use our shortcut of multiplying exponents, 1 times 4 is 4, which I got here, and 2 times 4 is 8, which I got here. If you want to evaluate this and also put 81 a to the eighth, that would be okay because 3 to the fourth power is 81. I would count either one of these, sorry I'm blocking it, as a correct answer on a quiz or a test. Let's do another one. Let's do, this should be example 5. Let's do x squared to the third to the fourth power. So these square brackets are just like parentheses, they're just for organization, and they mean the same thing, but we use different brackets. We can tell these are on the outer level and these two are on the inner level and go together. So my shortcut for taking a power to a power is I multiply the exponents. 2 times 3 is 6, 3 times 4 is 24, so this will be x to the 24th power. And then for our next example, this one will be example 6. Let's do -4 times m to the fifth power, n to the second power, to the third power. And I'm not going to write this one out, I'm going to use my shortcut. So remember, the shortcut is multiplying. What invisible exponent is on the -4? It should really be an invisible 1. 1 times 3 is 3, so I have -4 to the third power. 5 times 3 is 15, so m to the 15th power. 2 times 3 is 6, so I have n to the 6th power. And we're going to do one more example. For example 7, let's say find the volume of a cube if the side length is, let's do 4m squared n to the 4th inches. So if you think about the volume of a cube, we do length times width times height. But in this case, the length, the width, and the height are all the same because it's a cube. So I'm just going to say s for side length. Since they're all the same, I'm just going to write s times s times s, which we know is really s cubed. So if one side length is 4m squared n to the 4th, then the volume of the cube would be this side length cubed. Then we'll use our shortcut. This really has an invisible 1. 1 times 3 is 3, so 4 to the 3rd. 2 times 3 is 6, so m to the 6th. And 4 times 3 is 12, so n to the 12th cubic inches would be the volume of this cube. Or you could evaluate 4 to the 3rd. 4 to the 3rd power is 64, so you could also say 64 m to the 6th n to the 12th cubic inches.